Alright, so this is Euler's identity, a brief explanation of the concept. So Euler's identity was invented in the 18th century by Leonhard Euler, a Swiss mathematician. And he helped pioneer this type of equation, this equation specifically, his identity, that included all 5 mathematical constants. Now what that means is that these are 5 numbers that via constant mathematical testing and application, they can all solve very complex or relatively complex things with the same success rate. Essentially, whenever you apply these things to a formula they can be applied to, they will solve them. And these are things that are kind of baffling or interesting because they arise from, I guess, interesting scenarios. For instance, pi, a very popular constant and a well-known constant, is that kind of thing. Like, you wouldn't think that, how can every circle have this exact same ratio between radius and circumference? Well, it's 3.1459. It's basic math. So this equation includes these 5 constants you see here. So the breakdown is, the first is e at the start of the equation, which is similarly to pi, is a string of infinite numbers, a decimal, but is compacted into this little symbol, or sometimes just to quickly read it out as 2.71828. It's the solution to the infinite number series and the infinite interest accruance series, both of which are these also infinite, very long equations that constantly add this set interval, like for instance 1 over 1, 1 over 2, 1 over 3, 1 over 4, infinitely, and they both eventually even out to 2.718, which means the mean solution to both, like if you added them forever, they would roughly come out to this number. Not even roughly, like pretty precisely. And that's just interesting because you wouldn't think that infinity would have such a concise number, but it does, because it's just the average. It's about the center of the equation's many add-ons. Next is I, which is the square root of 1 over 1, or not square root, no, yes, square root of 1 over 1, or square root of negative 1, that accounts for the negative square root paradox, which is when you try and find the square root of a negative number. Next is pi, 3.1459. It's the ratio between the radius of a circle and the circumference, meaning the circumference of a circle is 3.1459 times the radius, always, no matter what. 1 is a mathematical identity, meaning whenever you multiply by it, you will get the same number as you started with, and 0 is something with no value. E is practically used in the real world by banks for compound interest, and E is specifically used to calculate for that infinite debt or infinite interest accruance series to help factor out that sort of possibility in debt. So the equation or formula commonly used is FV for future value, how much you're going to have in the future, or O in the future. PV, present value, how much you currently have given the bank. E, 2.71828. And then e to the power of R, which is the interest rate of the specific bank. Many banks have different interest rates. And time in years, which is how long you have owed this debt. And this is in years, so it's assuming that T is 1T is 1 year. So if you start with $100 and the bank's interest rate, this specific bank's interest rate is 3% every year, they charge you 3% each year, how much money would you owe after 5 years? So you start with $100 as your present value, then you multiply by E, your constant, and then you put that to the power of 0.3 for 3% interest times 5 for 5 years. And that'll give you $448.16. And this is used very commonly by people to find out how much they're going to owe a bank in X amount of years. And some banks charge more frequently, like maybe twice a year, 3 times a year, every month is quite common. And the interest rate also tends to fluctuate, not as much, because if it was fluctuating too much, then the bank would lose customers. But that's the basic idea of how E is used. Next is pi. Pi is commonly used to find the circumference of a circle when the radius or diameter is known, or the other way around, which is pi r squared. 2 pi r is when you have the radius and you want to find the circumference. So pi has been very useful in construction since it was discovered, because you could essentially only have to know one length, just one plank or board or pole that was your radius, and then you would know how much material to buy for the circumference by just multiplying that amount using 2 pi r. And this would save a lot of trial and error and money and guesswork. So for instance, just a quick equation with it, if you have a circle with a radius of 5 centimeters, what's the circumference? Plugging that into 2 pi r with 5 for r, you have 2 times pi, 3.14159, times 5, which would give you 31.42 centimeters. Finally is I, which seems a little daunting, like how could that apply to real life, but it definitely does. It's used for alternating electrical circuits. So since I can represent a negative or a positive depending on how it's squared and such, it's often tacked onto the end of a number that is representing the wattage or the amp or the amplitude of a circuit. So you would have, say, a circuit that's giving out 12 watts, but it's going to be giving out 12 watts in positive and negative charges depending on the circuit's configuration. So you would just write that as 14I, with I representing the switch to negative that would change that 14 wattage to a negative 14. And it's just that simple. So finally, back to Euler's identity is e to the power of I pi plus 1 equals 0. And you see these three abstract constants grouped here, and then your two sort of explicit constants grouped here. And there's just a lot of beauty in this equation, its simplicity, how it does actually equal 0 when you do all the math, and how Euler managed to combine these 5 now fundamental constants into one concise equation.